Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the 2016 JEE Mains Physics question paper. Let's do the next question. We are given a uniform string which has a certain length and a short wave pulse is introduced from its bottom end. And this is a heavy string, which means the tension will not be the same throughout, which means the velocity will not be the same throughout, so we'll probably have to integrate. This is the top. Let's say we are at a distance x above and it moves a distance dx. So we need first of all the tension at this point. For that we can consider this system where you will have mg down and t up. So t will be equal to mg, but this is not the total mass. So it will be m into x by L into g. This is the tension. T is equal to m x by L into g. We know what the speed of the wave pulse is. It is root of t by mu. Mu is m by L. So this is equal to root of gx. So at this point, speed is root gx. The time taken to cross this distance will be dx by root gx. So what you'll get is dx by root gx is equal to dt. And now you just have to integrate. This goes from 0 to t. This goes from 0 to whatever distance L we needed to reach the top. So it will be capital L. And so what this gives me is t is equal to 1 by root g into x to the power minus half. So x to the power half by half, which means 2 times x to the power half. So root L, which is 2 root L by g. And we are given L is 20 meters. So L by g is 20 by 10, which is 2. So this is equal to 2 root 2 seconds, which means the answer is option 3. If instead it was a light string and there was a mass at the end, the tension would be constant everywhere, so the speed would be constant. But this is a string which is not the usual light case. It has some mass, so the tension is not the same everywhere. That's the basic principle. This completes the solutions. Thank you.